displacement of joint C. Take note, horizontal displacement at joint C. Okay, so we are focused on this joint, no, joint C. Okay, ratio. Now that the class composed of 1, 2, 3, 4 members, no, 4 members. But supposedly, if one of these is a roller, it will be unstable structure. So therefore, to avoid unstable structure but still maintain its determinacy, A and D is pin connection. Okay, this is still determinate structure, meaning we can still use the principle of equilibrium to solve the member forces here. Okay, so the load is 40 kilonewton horizontal applied at C to the right. Okay, and then there is a dotted line here, color red. This is how this is the our imagination of how the structure will deform upon the application of the load 40 kilonewton. Okay, this is how we imagine. No? So as a structural structural engineer, you have the ability to predict what will be the deflection of the structure like this truss if there is a load. Now here we have a 40 kilonewton load going to the right, so the structure will also lean to the right, but not totally collapse, no. So this is our assumption, maybe a best assumption of the how the trust is deformed. Of course, when you assume, you have to exaggerate a little, or else you cannot see the difference. Because in actual, we do not build a structure that will really deform a lot. No, in fact, you can barely see the deformation in your naked eye. Okay, so but in order to have contrast, so you have to exaggerate a little. So that's why here the red lines is not in concurrent with the line of the members here. Except for joint E and D, that joint does not move. Why? Because it's pin. But for B and C, those joint moves. Okay, because of the load. Okay. Now we are going to compute the displacement C. Okay. So using Castigliano's theorem, this is the formula, no? That the depiction is summation to n. You have the d in dp and in the LIE. Okay. In actually, big letter in is the axial force of all the members here. That's why it's a summation. Summation of n is the axial forces of all the members. Okay, like here, you have four members, namely A, B, B, C, E, C, and C, D. So they are here, no? A, B, B, C, E, C, C, D. Okay. So first, you have to consider the given. The last parenthesis here in the formula, the parenthesis L over AA is what we call the stiffness. No, this is the stiffness. Okay. They are constant. No. Can be, you can use the given. L can be determined from the geometry. The area is given also here, and the A. So meaning all of this inside the parentheses are constant, and then you can have you can tabulate it in a column. So like the second column, you have the length of all members here. So summation means all members. Okay. So and then the third column for the area, and then the third column is for the elasticity. Now this in is the axial force, no? So you do structural analysis here, like thrust analysis, using this 40 kilonewton load. So summation of N says that is the axial force of all the members. So if the load is acting at joint C horizontally to the right, then you can see that BC and AB are 0. So pwede ko na nimong kuhaon, no? It cannot affect the structure. So kasi sakay lang na sila. That's why it's here. Their actual force is 0 and 0. But for AC, this is tension, no? Meaning mainat yun siya, and then CD is compression. That's why you have positive 200 over 3 and then negative 160 over 3. Now, we apply load P, no, in line with the direction at the point where we are interested, and the question is, what will be the direction of the P that we are going to apply? Is it horizontal or vertical? Now, the answer is, because you are looking for horizontal, then P should be applied horizontally at C. Now, because you assume that the direction of the deflection is going to the right, then P must go to the right. Okay. So, the second is you apply a load like this. P, no, because you are interested on determining the C. Okay. So, that's why so in this case, you're going to determine the force by using with the load P. Of course, all the load here are in terms of P. BC and AD are 0. Okay, 0. Whereas AC is positive. AC is positive. Okay. AC is positive. 5P over 3. So the derivative of N with respect to P is equal to 5/3. There is equal here. Okay. And summation of forces Y, you have in CD equals to negative 4/3 P, then the derivative in dP is negative 4/3. So we need this one. We need this EC. Yeah, in EC 0. Okay. So in the formula, actually, the second part, the first parenthesis here is the in dP. That means this is for all the member. Okay, so we take the derivative of the 0 still 0, but even though if there is a value here, since you are going to multiply it, then the product will be 0. So it will be a waste of time to deal with these two elements here. So you are leave with AC and AD. Now this is supposedly positive. I missed this. No, this is the correction that I'm going to I'm mentioning a while ago. So 4.233 plus 1.083 is 5.316. So that should be the 5.316 in it. So that's the correction I am making. Okay, so I'm going to say that. Okay. Now, for our discussion this morning, instead of using the NDP, we will use another approach. No, we will use another approach to solve it. Okay, so to have a comparison of the problem of the methodology, I will use the same problem. Okay, what will I do is I will just change this. I will just change this to field 11. Field 11. Okay, and then the formula, instead of using this one, I am going to modify. No, I'm going to modify that into this. No, so that we are not going to, because so we are not going to derive this. No, that one. So what will be the formula is like this. I will make a formula equation. Actually, similar lang. Just a little one lang. Just a little modification. Okay. So ang mahitabuan na niya kay delta is equal to, we still have summation sign. submission. We still have the in, and then the next is I will have this one. Instead of using the NDP, I will use this. Uh, I will use parenthesis, but small letter n. Okay, and then you have another parenthesis. That's for the stiffness factor L and I. Okay, very similar actually. Only the second parenthesis is changed to small letter n. Okay. So muna na formula atong gamiton. Asa ba to? Wait lang. Okay. So instead of using this one, I am going to use this one. Okay. So still Castigliano's theorem, no? But this time I am going to erase the first formula. So I will erase that. Cut. So it is changed now with this. Because this method is unit load method. Unit load method. Okay. Finding the friction of a truss using unit load method. So basically, this formula came from Castigliano's theorem. Okay. So I will save this. I will save as lecture grade 11. Grade 11, 2021. Okay. So we have the unit load method. So find the horizontal displacement of buoyancy of the steel traction. Okay, so basically what we are going to do is we still prepare the same table, no? The same number of rows, no? So still prepare this one. So I'm going to drag some of this. Okay, so this is what will happen, no? Uh, there will be a column for the n, which is this one. I will highlight this. I will highlight that one with maybe how to highlight that. Uh, I will highlight that one first. Highlight. Oh, here. So I will highlight that one with a light color. Okay. So we still need the n, but this one instead of being dp, the derivative of n with respect to dp, we are not going to derive anymore, no? So meaning, wala tayo hassle sa calculus, but we have letter n na gamay. Okay. Kining n nga gamay, instead nga mag-apply ka og p, ang imong gamiton, 1 na. No? 1. 1. So, sa dinhi, so this will be our real structure. This is for the n, but for the small letter n, mao ni siya mitabo for the small letter n. So if you are looking for small letter n, you still have that structure, but this load is the one. Okay, and that one is one. Okay, that one is one. Okay. Ito sa isibog. Pwede siya pa to. So, wala lang diferensya, no? So, kini siya, kung mangita ka o in nga dako, this is what we call for the real load. Yeah. Kining in nga gamay, this is for the unit load. Okay. Kining pag-apply sa unit load is, kung siya, kanang, kung asa sab ka mangita og, like for example, in this problem, you are going to determine the deformation at C. Okay? At C. And then, based on our assumption, the depiction would go to the right, no? We need a horizontal pick 1 unit load going to the right because this is our assumption. No? So that's why we have a 1 here applied. Okay. You apply only unit load at the point where you are interested to determine the deformation. And the direction of the unit load will be according to how you imagine the deformation. Okay, since it goes to the right, so it goes to the right, but in the horizontal, it's already given that you are going to use horizontal load. There are only two ways, either to the left or to the right, but the best guess is going. Okay, so we have here system 1 subjected to 40 kilonewton, and what will be the member forces will be aligned here in column N. And then we have here another system, the same structure, subjected with a unit load. And we are going to analyze again the structure. And then makuha mo kita load to the member, we are going to put here. Now, the first column will be the name of the member, the same Japon. The second column will be LIA because we still need the L and the IA here. So we have to do this, and we can have this, no? We can have this, which is not okay. So assume na to nga kini siya nakuha na nato ni siya kini column N, no? So because this is what we did before, no? Okay, so we analyze the stress. So by joint, so we get in CD, EC, EB, and BC. So after analyzing it by using method of joints, we put here EB is 0, BC is 0, AC is positive 200 over 3, and CD is negative 160 over 3. Okay. Now we go to the letter N because mo lang siyang wala pa, no? So the letter N, so instead na P na siya, may muna siyang 1. So we are interested on the C, so that's 1. So if this is 1, what will happen? Small letter NEC. This is 1. NEC is 5/3. Okay, we do not need this. We do not need that. Okay. Summation of forces Y, we have that one. NCB is negative 4/3. Wala na na. Wala na na. So we do not need this. Okay. So as to the other member, they are 0, no? So like NBC and EB. So in EB is equal to in EB is equal to 0. We have also in BC is equal to 0. Kini siya small letter A siya. Okay. And this one is a subscript. Subscript ka. Subscript ka. So we have this 5/3. positive 5/3, we have negative 4/3, 0, 0. So what is the difference here is that we do not perform differential equation anymore, but we take right away what will be the answer because our unit load is 1, not K. So 5/3, negative 4/3, 0, 0. So you put that here in the column letter N here. So you have 0, you have 0, 5/3. So you perform this product N times L over IA. So this one will be 0, and this one will be the same. No, 200, you have 200 times 5 divided by 9. You have okay, 200 times 5 times 5,000, 200 times 5 times 5,000 divided by 65 divided by 210 divided by 9. 4.233. That's correct. So this one, carry on the sign, negative to negative becomes positive, so you get the same answer. Okay? So I'll save this. So balik class, by using unit load, mabuid nimo ang derivative, no? You do not have deriving the member force with respect to the load anymore. Okay? Because you apply a unit load already. So our example last meeting is just a classic one, no? But we have to modify it because that method is somewhat very mathematical because itabulit na nimo niya mo derive pag yun ka, no? Mo derive ka, so hassle na kayo. Okay, so this morning I introduce you another method without going too far from the Castigliano theorem. But what we do is we apply a unit load. If you apply a unit load, you do not have to derive anymore or perform differential equation, differential calculus anymore. Okay, because you apply a unit load P. So instead of using the derivative of n with respect to P column, you should have a column for little n or small letter n. So what is this small letter n? They are the member forces of the truss, okay? Because the truss is composed of many members, okay? So, wherein the load is a unit load at the point you are asked to determine the deformation. Okay? So, in our example this morning, uh, I have demonstrated that using the classic Castigliano's theorem involving differential equation, differential calculus, and using the same theorem but using unit load, we found out that the answer is the same. Okay, answer is the same. Okay, so we'll have one. No? So that will be uh, the most important one for this morning. So okay, so we do not need this, but I rather in uh, in solder in no, is are the member forces of the truss using unit load. Okay, unit load. But it doesn't have any unit. If it doesn't have any unit, then no unit. No? So that is how it is. No? Okay, so you have the N. That's why your in here has a lot of subscript in EC, in AB, in BC. So, yung ana, no? Ana, nasa ikuan. Nasa subscript. No? Ang subscripts. Okay? So, that's fun for today. So, we'll have another problem. No? So, we'll have another problem. I will, because we still have time, we will apply. No? I will say that this is example 1. Then I will make example 2. I will make example 2. Example 2 here. Okay. Example 2. Okay. Find the vertical deflection of point B. Point B of the loaded trash as shown. Area, let us say common IA is equals to what will be the area? 5,000 and 5,500 and maybe 500 is okay. What is the area here? Okay, 1,000. IA is 1,000 times 200,000. Times 10 to the 6. That's 10 to the 6. The something unit is Newton. Okay. 10 to the 6 Newton. I will make that real quick. For all members. Okay. So, ipadayon ako ang kuan. Ang problem, I will make an example 2. But this time, using the modified approach, using unit law. Okay? Wala siya. So, I am going to present again here. So, this will be my example 2. So, I type it. So, I for all members. So, I'm going to make a structure here. So, I put here solution. Solution. Okay. I will make a structure. I'm going to do a structure. Okay. Shape. Okay. I will make this bigger. Format. Alah, siguro yan ko na ko. Kalau kada ko. Ito. Okay. So, kana. Then, dianaw siya. Okay. Paste. So, I will make okay. Then the other one. Okay. Then I will paste it. Okay. Muna siya. Butang yung triangle. Insert sheet. Okay. One of this is a ruler. One is a pin. So this one is a pin. and one is a roller. So we'll put a roller here, roller there. So we can solve it mhm, using equilibrium. Okay, it's a roller. Yeah, you'll group them. I'll group them. Okay, group, 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 group. Okay, so let's group here, group. Okay, so we have now one structure. Ah, nabili na isa. Group ko na ako. Okay, okay. So that's the structure, and then with respect to letter A, that's A, that's B, that's C. And the one here is B. Okay. Now let us say doon ay load din buta na natugload. Mulam na lang ito din araw. Ito na, lumanda na. Ito ka. So let us say nga doon na siya load diha nga. TN. Okay. So that is it, no? 50 kn. Now the distance here, the height here, I put a height. Okay, para kuan natay measurement, no? Where is it say? Measure height. Okay. Ano siya? 4 meters. 4 meters. Ini sa silong, ano siya, matuog. Sa pagkaan ng 50 diyan. 50. Ano siya, wala na yan. Green siya. Green. Kini siya, muna ko siya 6 meters. Okay. So there are actually 1, 2, 3, 4, 5 members, no? So this is the tabulation because this kind of problem can be best solved if you make a table, no? And our formula actually is this one. Using unit load method. The formula is one. We will borrow this formula. This is the formula actually we are going to use. Okay. Then we make a table for 1, 2, 3, 4, 3, 4, 5. So we have at least insert a 6 column, 2, 3, 4, 5, 6. Then maybe that number of rows. No? So this is should be for the member. So there will be 5 members. You have to know all of them. You have AD, BC, you have AD and BD, ED, BD, and then you have DC, DC. Now we need to row for the summation. So insert row below. This will be for the summation because we need the summation here. So summation, what is it? Symbol. Then we will do is we put that in the middle. And maybe this one will color shade it with this color. Okay, so you have to remember. Now you can have for the length, maybe mm. You have for the IE. This is Newton. You have for the N. And for the N, may gamay din. Muna din siya. Ang create the last column. Insert columns to the right. This is for the N, multi N, in L divided by I. So you can have this for EB, you can have this for BC, you can have it ED, BD, and DC. Now, if you are going to sum all of this, if you are going to sum all of that, this is this one. We are going to sum all of this. All of that. We are going to sum all of this. So you have the summation, okay, which is this one. Okay. So you can have you can have this over here. Okay. You can have that there as well. Okay. So this one is doable. Okay. So that's how you are going to solve it, class. No. So you don't have to perform derivative anymore. No. No differential equation. So what we will do here. Okay. So what happened, class, is that we use the same approach, no? We prepare a table, okay, table. So the number of rows should have it should have a number of rows that will accommodate all the members there. As we counted, there are 5 members, so I prepare 5 rows. No? Then I prepare a column below, just below all the members, to perform the summation because the formula involves summation. Okay. The first row is just a heading of what you are going to write in every column. Now, how many columns you are going to prepare? Well, of course, first column is for the member identification. Okay, member identification can be members can be identified through its joint, no, like member AB, member BC. So it can be like that. Some also have a unique way of numbering members. So the number member as numbers still member 1, member 2, member 3, member 4. But every designer has its own way of identification of member. Ours, we use the nodes of the member as its identity. Okay, that's why we use A, B, B, C, C, D. So that's for the first column. Now for the second column, of course, you started with the Asian one, so length are easy to fill up. So you have the length. Now, units depends on unit. You can use meter or mm. So in my case, I use mm so that straightforward, no? Okay. So all the length of members should be there. The next is you have the product of the area and elasticity. Now the unit, if you are using an area of squared and your elasticity equal to uh, Newton per squared, therefore the product of the area times elasticity will become uh, Newton. Okay, 20 Newton. So, and then the next column will be for the N. No? So, N is the member forces of all the structure due to the real loads. So, kung saan ang na-load yun yan. No? Then, the small letter N is you apply unit load at the point where you are interested to determine the deformation. What direction? Of course, it's vertical. Okay, so that's how we're going to do it. No? So, what happened here? So I'm going to continue. No? So I'm going to continue. So we will imagine how the structure will deform when applied to the load. No? So that is what we are going to do now. Where is it? Okay. So if I'm going to make another shape here, so I make it here, but I will just color it red. Okay, red. And maybe I'm going to make that a little bigger. Okay, and then maybe the kind of line is I'm going to use that one. Okay, and then the color is red. Kita punta sa copy that, copy, paste. So, okay, so C might move there. C might move. Okay, because it is a roller. Okay, might move there. Then paste, then maybe B to deform a little there. So that's how I imagine it. Because D, of course, because there's a load here pulling the D downward. Then might be that this one will move a little. Picted siya gamay na D. Then this one move there. And then there. Okay. Then the last is okay. So that will be the deformed structure that as I imagine it when 50 kilonewtons applied here. Okay, 50 kil. Now I am going to group this to 3, 4, 5. One, two, three, four, five. Okay. Okay, so and that. So for if you are interested on letter N, big N, I will copy this. Uh, I will copy that, copy and then paste again here. Okay, I will make it small. And then copy again, paste. So put that here. Okay, so if I'm interested on looking for N, I will make this insert table here. Paste. And just put it there. Okay. Okay. So if I am interested on letter big N, I will put here in. This will be for small letter N. Okay, small letter N. If I am interested on N, I will use this load. Okay, I will have a 50 kilonewton load here. Yeah. But when I am interested in letter N, I will apply a unit load here. 1. Now, this is letter B. This is A. That is B. That is C. Same also here. That's A. That's B. That's C. Remember that I am interested on vertical load, so I am going to apply a load here. Copy. Vertical load. And yeah, vertical load. There are two possible way of a vertical load. It's either up or down. But I use down. Why? Because B is really down. Now, if you choose positive, is it okay? Okay lang gyapon kung naonin mo. Naonin mo. But you will get a negative answer. But the magnitude is already okay. So now, since I already know my best guess is that B will go down, so I will put a vertical load, unit load here, acting down. So that's how it is. So this one is for the small letter N, this one is for the big N. So N are all the members actually. This is D. Okay. So that for this case, you're going to fill this up. For this case, you're going to fill this up. And for the AE, since it is constant for all the members, so I'll put here 200, 1, 2, 3. I'll just see times 10 to the 6. That's Newton. Okay. Then copy all of that. Then paste it here. Okay. Now for AB, that's 3,000. Now ED is 5,000. BD is 4,000. BC is 6,000. And for DC, you can compute that for 16 plus 36, 52 square root of 52. That's 7211. 7211. 7211 mm. Okay? 7211 mm. As for the N, well, okay. So we will compute, no? Calculate member forces due to 50 kN load. Okay. Now we will make five one. We will make maybe a table. 1, 2, 3, 4, 5 here. Okay. So this is for now. The reaction here, if I'm going to consider, the reaction. So first, I will solve the reaction. I have this is no issue to you. The reactions. Okay. Uh, REB or REY is equal to uh, 50 times 6 divided by 9. That's 33.33. That's 33. 100 divided by 3 kilonewton. And RCY is equal to 200 divided by 3 kilonewton. Okay? Ano? 100 divided by 3? No, really. I think this is 100. 100 divided by 6. By 6. 100. 100 divided by 6. Yes. 100 divided by 6. Okay, that's it. Okay. And REX is equal to 0. Okay. So I hope this is not an issue to you. This is only a reaction. Okay. So we will see if BDE joint E here. Na isang sunod. I will only show an example, joint A. Now, at joint A, if you have this, then you sum up forces y equals to zero equals to 0. You'll have an equation like this. You have an equation like this. 100 divided by 3 going up. Then you'll have minus plus. You'll have plus cosine of angle plus 0.8 in A B is equal to 0. In ED equals to 0. Okay? So in ED going there, in ED. So there are only two forces acting, so you'll have in ED equal to, that's a negative. That's a negative. So 100 divided by 3, 100 divided by 3, divided by 0.8, you have 41.66. 41.666. So yeah, or this is also 500 by 12. 500 divided by 12. Here, I put it here. That's 500 over 12. That's ED. ED is negative 500. I think I will make that into kilonewton. So 500,000 divided by 12. So that's the value of N. Okay. Now, I am not going to solve all of that. So I will just only up to summation forces X. Forces X. So I will have zero 0.6 in AD plus in in ED plus in ED equals to 0. So in ED equals to positive. Okay, this one is a subscript and this one is a subscript. So in ED is a 500 500 divided by 12 divided by 26 69.44 69.44, or that is 500 over 12 500 over 12 times 5 over 3. So okay, so we have 2500 5 times 500 5 times 500 2 500 divided by 36 2 500 divided by 36 kilonewton. Okay, so you have in EB like that. In EB, that okay. So you have EB is positive 2 500 1 2 3 divided by 36. So that's right. Okay, so that's it. Now this will be for I will proceed to another joint, no? Like if the joint B, this is simpler. Okay, emission forces X equals to 0. Okay, we have for Y forces X. We have minus in EB plus in BC is equal to 0. We have in BC equals to positive 2,500 divided by 26 EN. Condition of force is Y. We have in BD minus 50 is equal to 0. Then in BD is equal to positive 50 EN. So these are all subscript, 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 subscript. So what we got here, BB is positive 50, 1, 2, 3, and BC is the same as AB plus 2, 500, 1, 2, 3 divided by 36. Okay. Now for DC, kami bahala yan, no? Now, if you are going to calculate for the small letter n, I can use here the second column. No? Like, for example, I will use if the joint A here. Okay? So, but here I'm going to use small letter n. Wait. Small letter n. There. So I have n here. I got my add in to my, and there's that. And there's that. Once you got my then wala na tayo load. Okay. So for unit load, so this is for 50 PN load at B. Reaction is like that. Now for we're also going to compute the for unit load B. We'll have also this one. Okay, that this one will be equal to 1 times 6 divided by 3. 1 times 6 divided by 3 is 1 times 6 divided by 3. 1 times 6 divided by 9. This is 2/3. Okay, 2/3. Then this one is 2/3. 1 divided by 3. So if you add this one, you have a unit load. Hello. Oo, isa ni. Ha? Oo, isa man. Sige, ano mo asa natin? Naara ko sa town. Naara ko sa town. Hindi ka po dito, gyapon. Gyapon, tawag lang. Oo, sige, patawag na siya. So, this is the reaction due to the unit load. Remember that the reaction, you have a unit load here, so the reaction is, naturally, it will change, not 100/3 or 100/6. So, that will be my load here. This will become 2/3. 2/3, okay? Also, may tabuda na 4/5. 4/5. This will be 10/12. Negative 10. So 4/5. So 5/4. Negative 10/12. Okay? 10/12. So if you have 10 divided by 12, okay, you have 2/3 is equal to 4/5. So you have 10/3. Then 3/5. So you have 10/5. Will be 10/5. So negative 10/12 here, ED. Negative 10/12. And then the other one is 10/5 EB. Positive 10 divided by 5. Okay. Natural, if for this one, we are going to copy this one here. So this one will change it to letter N. This one will change letter N. So letter N. Here is that. Here is that. Here is that. This one will be 10/5. 10/5. And this one for NBD. NBD. You have -1 here. And this is 1. So NBD is 1. NBD is 1. plus 1, and this one plus 10 divided by 5. Okay. So if you can perform all of this, I will do the operation. You have 2,500, 1, 2, 3. Okay, I think this one and the zero here will be cancelled. No? So n is 2,500, 1, 2, 3 times 3,000 times 10 divided by 36 divided by 5 divided by 200, 1, 2, 3, 4, 5, 6. We have positive 2.0833. This is mm. This is mm. Unit here is mm. Okay. The unit here is Newton. Newton. No. What? So, it's mm. Now, this one here is will be double. Is positive 4.1666. Okay. And here you will have positive. Okay. You have n, which is 500,000, 50,000 only. 50,000. Okay, one siya. So, for this one, this is positive still. You have 4,000 times 50, 4,000 times 50, 1, 2, 3, divided by 200, 1, 2, 3, 4 times 6. This is 1 in n. Okay. So, as for this one, you perform, then you sum all of this here. You can take the sum. You can take the sum that no. You can take the sum. Okay. And this sum will be equal to this. Equal to that, no sum. That will be the deflection at C. No? So that's how you do it, class. No. So okay. I will save it. Okay. So that's how you should how you determine it using unit load. Okay. So as to your assignment class, you determine the depiction of the class, but we will say that the load is no, is see, dito si pila ba yung loadan eh. Okay, you may use no this one. This will be your assignment. I will put it here because I'm going to load this, to upload this. So this will be assignment. So here you'll have 80, no? 80 kilonewton. Okay, the load. Okay. So bali. So that is how you are going to determine the deformation using the modified Castigliano's approach, wherein we do not have to do differentiation, but we have to apply a unit load. So unit load is the K, no? So you apply unit load at the point where you are interested in determining the deformation. If you are interested in downward deformation, then apply a downward unit load. If you are going to determine a a deflection, horizontal deflection, then apply a horizontal unit load. Okay. So I have presented that this morning, and then as I have told you, you will have an assignment. So the assignment is similar to the last problem that we had. No, I have already put it there. I am going to upload that today. After this, I'm going to upload that and then just download it now. That served also as our notes, but in the last portion will be the assignment. I just copy the problem actually and just change the load. So basically, you follow the same format. You follow the same format. No? So so I hope that you can apply the method on other class structure, no, of the same problem na pakita ko ng deflection. Okay, but I don't. That is not the only method, no, but that is one of the classic method. No? So pang board exam style na siya ng method. Gamitan lang yung table. Okay, so do you have any question, class? Hello? Oh, time na no? Okay. No question? Okay, so just wait for the notes to be uploaded and the assignment is there. Okay, I'll also paste a page where you submit that assignment. And the deadline will be Monday next week, no? Monday next week. Okay. And then as I have told you, your midterm exam will be next week, no, but not on the later part of next week. So that will be Thursday next week, a week from now. Okay, class. I have to sign out because I still have another class.
Thank you.
Thank you.
Okay, sir.
Okay.
Thank you, sir.